Hi everyone. As I'm going through this PowerPoint, please take notes. This is an ed puzzle as well, so throughout the PowerPoint there will be several questions that come directly from this PowerPoint. So this is Unit 6, Topic 5, Fossil Fuels. So we've been talking about them in class, but this is going to be a more in-depth overview of different ones, as well as combustion. So this picture here on this page is showing the life cycle of a dinosaur. So with that, dinosaurs, after they've died, their bodies have been compressed, become oil. That oil is refined to become plastic, and that plastic is used to make plastic dinosaurs. So fossil fuels are derived, which means come from, biological materials that fossilized millions of years ago. So a fossil is not the actual organism. It's often like hardened organic material, stone, mud that went in and filled the area where their body was before they passed away. With this, it's like the remains have been compressed into either coal, if it's a plant, oil, or natural gas. They form in anaerobic conditions, anaerobic meaning areas without oxygen, and they are non-renewable. So there's a finite supply, meaning that at some point in time they will end. Here we see the difference between coal and oil and gas fossil fuel formation. Big difference and key thing for you to know here: coal is land, oil and gas came from marine environments. So it doesn't mean necessarily that they're marine environments today, but at the time when this happened, it was a marine environment. So for both coal as well as oil and gas, heat and pressure are the key things. So heat and pressure cause the remains to become compacted and to actually change forms. So in the case of coal, changes from peat to lignite, then to bituminous coal, and then to anthracite. Whereas with oil and gas, it's really into oil that then starts to leak back up to the surface. Complete combustion. So in the past, this isn't something that I covered during APES, but the course got redesigned this summer, and this is now one of the knowledge aspects for this topic. So combustion is basically, we use combustion to talk about when something's burning. So during combustion, oxygen combines with a hydrocarbon, so some hydrogen and carbon that are linked together to form water and carbon dioxide and produces heat. The general form, it's some amount of carbon and hydrogen atoms plus oxygen yields carbon dioxide as well as water. An example is C6H12O6, which is glucose, plus oxygen yields carbon dioxide and water. We're basically burning fuels to make energy. So we do that to make energy that we can use, and that's what our bodies do as well to make energy for our daily functions. So combustion, we make heat energy by burning fuels in one step. So here, fuel, it consists of carbohydrates, oxygen is input, and it results in carbon dioxide, water, and heat. Aerobic respiration, so aerobic meaning requiring oxygen, is a process through which ATP energy is made as well as some heat. And this is what our cells do to make energy. So food containing carbohydrates is used as well as oxygen, and it yields ATP, carbon dioxide, water, and then heat. So this table is comparing the two processes of cellular respiration and combustion. So cellular respiration is a slow, controlled process, whereas combustion is very fast. And cellular respiration happens at the temperature of our body, which back in the 1800s, a guy did a study saying that it was 98.6, but they recently found that it actually is closer to 98, or actually a little bit below. So it's happening at that temperature, whereas in combustion, it's happening at much higher temperatures. And cellular respiration happens in living cells. Combustion can happen anywhere. During cellular respiration, energy is released in steps and stored in ATP, whereas combustion, energy released in a single step in the form of heat and light. There are two types of combustion, so there's complete versus incomplete. During incomplete combustion, there's not enough oxygen present, so the leftover carbon is getting released as soot and carbon monoxide. During complete combustion, we see there is 8 oxygen, 4 methane. So remember, CH4 is methane. It yields 4 carbon dioxide and 8 waters. In incomplete combustion, there's 4 methane molecules, 7 oxygen molecules, and it yields 2 carbon monoxide, as well as 2 carbon dioxide and 8 water. This table is further going into the differences between the 2 types of combustion. So complete combustion is on the left, and the pictures on the bottom left, the ones with the blue flame, show complete. Incomplete is on the right. So during complete combustion, there's sufficient, meaning there's enough oxygen. Products are carbon dioxide and water. A blue flame is produced with high energy production and no smoke. During incomplete combustion, there's insufficient, so not enough oxygen. Carbon monoxide and water are produced. There's a yellow or orange flame. Smoke and soot are produced, and there's low energy production. So this is a picture of incomplete combustion with forest fire or slash and burn over here. In terms of other outputs, through complete combustion, there's carbon dioxide is produced, and that contributes to global warming because it is a greenhouse gas. Through incomplete combustion, there's carbon monoxide, as well as smoke, which cause air pollution and lung disease. So now we're going to talk about the specific types of fossil fuels. So coal is the most abundant, but also the dirtiest of the fossil fuels. It's a solid fuel formed from the remains of trees, ferns, and other plants, preserved 280 to 360 MYA. MYA stands for millions of years ago. It is the most common fuel for electricity in the U.S. It is ideal for stationary combustion applications, such as those in power plants and industry. Stationary meaning that they don't move. So it's used by facilities like buildings primarily. You're not going to see a coal-powered car or like a coal-powered boat. Actually, you may see some coal-powered boats like tugboats, but in general, they do not use coal anymore. So this is a coal burning power plant. In step 1, coal is mined and transported. In step 2, coal is burned in the boiler. So the boiler is the furnace. Here, coal is burned and it heats up water. So water's coming in from a river, coming up here, being heated up, and as it's heated, it's turned into steam. This is how the energy is transferred. So it's transferred to water in the form of steam, and that steam turns the turbine. The turbine then turns the generator, and the power or the electricity is then transmitted. Key things to remember here: water, as well as emissions. So water is an essential part of generation of electricity. Emissions are something that are produced as a side effect. So with coal, there's a lot of emissions. Coal is very dirty to burn, and as a result, there's a lot of pollutants that are produced. This is a graphic showing the percentage of global fossil fuel emissions that have happened since you were born. So you would look at it by figuring out what age range you fall into. So you guys are going to be somewhere in here, and then seeing how much it's changed. So in your guys' lifetime, global fossil fuel emissions have increased between 30 and 40%, which is pretty crazy. This graphic is showing the 3 different types of coal. So just like the graphic before, heat and pressure are an important thing to remember. So through heat and pressure, peat, which is biomass, or it's biomass and a biofuel, so not a type of fossil fuel, gets converted into lignite, which is a brown coal. Lignite has a low heat content, low sulfur, and it's limited supplies in most areas. This then becomes bituminous coal, which is a soft coal. It's often used as fuel because of its high heat content, and it's very abundant, but it has a lot of sulfur, which when it's burned produces sulfur monoxide or sulfur dioxide, which contributes to acid rain. And then through heat and pressure, this becomes anthracite. And anthracite is hard coal. It's a highly desirable fuel because of its high heat content and low sulfur content. Supplies are limited in most areas. So this is a map showing the major coal deposits of the world. So the United States does have quite a bit, both in the continental as well as in Alaska. Australia has a bit as well, and so does Russia and China. This is a map showing the specific coal reserves in the United States, so based on the type of coal. So anthracite, we have some in Washington as well as over here in Pennsylvania, and that's where I'm from. So it's a coal country. So anthracite isn't super abundant in the States, and that's why it was so heavily mined in Scranton. Here are the advantages of coal. So one of the biggest advantages is that there's abundant reserves, especially when we compare it to oil and gas. So that's represented in two different ways on this slide. So the graphic in the bottom left corner here shows the amount of each fossil fuel we have left based on years. So we have 46 years left of oil based on our current consumption, 63 years left of natural gas, and 119 years left of coal. Up here, we have the amount of oil that's been pumped as of today, the amount of oil left, and the amount of days left to the end of oil. We then have the same for natural gas, so how much there is left and how many days left in coal. So we have 149,000 days left of coal, whereas only 15,000 days to the end of oil. Another advantage is how easy it is to extract it. So coal can often be extracted through surface mining. So surface mining, they aren't actually digging like those mine shafts. They're doing it at the top or at the surface level, often through a process called mountaintop removal, where they're basically cutting off the top layer of land to get to the coal veins. You don't need a lot of technology for this, and it is fairly low cost. It also can be easily stored for future needs. So I think in class, I mentioned to you guys that my Nana's backyard is where a railroad used to go through, and there's actually like anthracite coal back there. So I could go into her backyard, find anthracite coal, and that coal could still be used for fuel burning. We don't have to worry about it having degraded or the fact that it's been out in the elements. It's still pretty much as good as today as the day it was mined. Ease of transportation is another big benefit. So there's no pipelines or extra security needed. So it can be put into trains and moved from one place to another. So that's Pennsylvania. Trains used to be a really big part of the economy there, primarily because they were used to transport that coal. And I think I told you guys too a story about how my grandfather or my great-grandfather got arrested once because he was walking along the tracks and he was picking up coal that had fallen out, and the police caught him and arrested him, saying that that was coal that belonged to the company, like the mining company, even though it was stuff that had fallen on the side. Another advantage of coal is that it needs a little refining, meaning from the time it comes out of the ground to the time that it is used, not much has to be done to it. Disadvantages of coal. So one of the disadvantages relates to surface mining, which is an advantage in that it's easy. It's a disadvantage in what like the byproducts are. So tailings are material left over after the process of separating the valuable fraction from the uneconomic fraction of an ore. So tailings are different from overburden. Overburden is the waste rock that has been displaced. Tailings have been processed and therefore aren't technically overburden, but there's still parts that are not needed or wanted. Coal is also very dirty and leads to a lot of oil or air pollution. So there's many impurities that are released when coal is burned. Sulfur, mercury, lead, and arsenic. Leads to sulfur dioxide as well as airborne particulates. Coal is 60 to 80% carbon, and most of this is converted into carbon dioxide, which contributes to atmospheric increases for temperature. The graph at the bottom shows the carbon content of fossil fuels. So coal has the highest carbon content, followed by oil, followed by natural gas. Coal also residual ash. So 3 to 20% of the coal remains behind after burning in the form of ash. So this is a picture showing a huge ash or water spill back down in Knoxville. And it took over 5 years and $1 billion to clean up. So all of that black material you see there is coal ash. I'll put this on Google Classroom if you want to see these. It's not something you have to watch right now, though. A tweet from our president saying America is blessed with extraordinary energy abundance, including more than 250 years worth of beautiful, clean coal. We have ended the war on coal and will continue to work to promote American energy dominance. Yes, we do have a lot of coal left, But the beautiful clean coal, that's where it's a bit of an oxymoron or just a flat out lie. So petroleum is cleaner than coal. It's not something we often think of, but it actually is. So petroleum is a fluid mixture of hydrocarbons, water, and sulfur that occurs in underground deposits. So coal is solid, petroleum is fluid or liquid. The fluid nature makes products, so oil and gasoline, more suitable for mobile combustion applications like in vehicles. Formed from phytoplankton. Phytoplankton are plant plankton. Phytoplankton are responsible for more than half of the Earth's oxygen. And these remains are from 50 to 150 million years ago. Porous rocks, so those are rocks with those large pores, and them are covered by non-porous material. Over geologic time, the algal remains fill in the pores and form petroleum. So basically, if you think about, if you've ever seen like a pumice stone, pumice stones have those holes in them. Think about like pouring material in there, so pouring like sand in, and that sand then over time becoming compacted and forming petroleum. Petroleum is less dense than rock, so as the rock deforms or breaks down, it migrates closer to the surface where it can be drilled and extracted. It's then transported by pipeline or supertanker to a refinery. Crude oil. So crude oil is liquid petroleum that's been removed from the ground. This cup here is a picture of crude oil. The natural gas is burned off or extracted for separate fuel. Crude oil can also be refined into tar and asphalt, gasoline, diesel, and then kerosene. They differ based on the temperature at which they boil. So this is a picture showing distillation of crude oil. So crude oil is input, it is heated up, and based at the temperature at which it is cooled, it then relates or becomes these different components. So there's gas, naphtha, gasoline, kerosene, gas oil or diesel, lubricating oil, heavy gas oil, and residual. Oil refining. So if you remember, it said that coal is pretty easily refined. Oil is not. It's a complex and dangerous process. It requires a significant monetary investment. 1 barrel of oil is equal to 160 liters or 42 gallons. So if you think back to the math that we were doing, I think last week, this is a conversion that you wouldn't be required to know for the exam, but it is something that you could be set up to do. So it may say you get like 50 barrels are extracted and converted in, like, how many liters is that, or how many gallons? They would provide you with the conversions, but you just need to set it up the correct way. So this is showing what is left of oil. So these are proven reserves in billions of barrels. So Canada has 178.8, US is only 21.4 billion. Mexico has 12.9, Venezuela has almost 80 billion. Saudi Arabia has the majority, with having 264.3 billions of barrels left, followed by then Canada and then Iran and Iraq.